Continuing with 5.2, we're in 5.2b, verifying trigonometric identities. Alright, so at this point we have been given a problem on the left, problem on the right, and find the most difficult one and try to simplify it so it looks like this one. Alright, this next section that we're going to do is taking a different method as far as doing these verifying identities. And what we're going to do is we're going to have a problem here equals problem there. And we can't make one look like the other, so what we do is we try to make this one look like something, and we try to make this one look like something, and that something then matches so they equal each other. So we kind of do both sides, not necessarily at the same time, but we try to make the left-hand side equal something that we can make the right-hand side equal the same thing. And that'll make it easier for you to do those. So let's look at example number 5. Okay, so there's the problem. And one of the things I did different is I used theta instead of alpha. It's just, I don't know, just a preference, I guess. Doesn't really matter which one you use. Alright, when I look at both sides of this, they both look pretty complicated. So, what I'm going to do is I'm going to take and work with each side, and I'm just going to pick one side and work with that, and then go to the other side and work with that, and see what I can simplify it to be. So let's start with the left side, and see what we can do here. Alright, so let's look at the left-hand side, and this is kind of hard to come up with what you're going to do here to simplify it, but we don't like the secants and tangents. We're going to try to make them sines and cosines if we can. So we're going to look and see what we have with secant, and with secant we have that. And really, if you look at that, if secant of theta equals 1 over cosine, then secant of theta times cosine of theta equals 1, right? So if we could get this out of this, we would have a 1 there. So what I'm going to do is I'm going to multiply the, in fact I'm going to move this over a little bit. I'm going to multiply the top and bottom by cosine over here, because that'll give me cosine times secant, which is going to be equal to 1. But I have to distribute. So I'm going to get cosine secant plus cosine tangent over cosine secant minus cosine tangent. So see what that gives me. That gives me a 1 for here, over 1 for here. Okay, so that's looking a little bit easier. Alright, so what do I know about about tangent? I know that tangent equals, so I'm going to leave my cosine, and I know that tangent equals sine over the cosine. And why did I change that? I don't want tangent there. So then I've got 1 minus cosine sine over cosine. And actually the reason I did that, look, that cancels with that and that cancels with that. So this turns into 1 plus sine of theta over 1 minus the sine of theta. Okay, that's really about all I can do with that. So that's as simple as I can make it, and not only is it simple, it has the sign in it. So I'm going to take that and save it, and then start working on the right-hand side. Okay, so cleaning all this up, notice that this is what this is, simplified. So what I'm going to do is I'm going to take that and kind of move it over here. Now we're going to work on this right-hand side, this over here, and see if we can make it look like this yellow here, 1 plus sine of theta over 1 minus the sine of theta. So let's get started on that one. Okay, so this is going to seem weird here, but we're going to look at this here as a trinomial, and notice I have a squared, I have a sine of theta, and I have no theta. So I'm going to flip this thing around, and I'm going to rewrite that numerator as sine squared of theta plus 2 sine of theta plus 1. Okay, now it looks very similar to, so that looks very similar to x squared plus 2x plus 1, doesn't it? The only difference is we have sine of theta instead of our x's. Well, let's factor that and see what we get. So when we factor that, we get, see what kind of answer we're going to get. We get an x there and an x there, two numbers together, 1, 1, if that's a plus, and that's a plus. So we get x plus 1, the quantity squared, right? For when we factor this down. Same thing is going to be true up here. We just substituted x in for sine. So what we're going to get, we're going to put our sine back in. So we're going to get sine of theta plus 1, the quantity squared. So we're just going to rewrite that over cosine squared of theta. Okay, so it's not too far off of this. We did get rid of our, well, I guess we still have sines, but we did get rid of this 2 and this 1 and kind of made it a little bit easier. Now let's go from here and see if we can make it look like that. Okay, so I just kind of moved everything around, cleaned it up, got rid of all the work, and moved this from over here to over here. Alright, so we need to make this cosine right here into a sine like we do up have there. So sine of theta plus 1 squared, and if we look up here at our identities, cosine squared, there's a cosine squared, that equals 1 minus the sine squared of theta. So I'm going to replace this cosine squared here with 1 minus sine squared of theta. I'm moving this over to the other side. So that'll be 1 minus sine squared of theta. Okay, notice it's starting to really look like 1 minus sine squared plus 1, that's just flipped around, but I've got the squared things there that are still in the way. So let's see what we can do here. This is actually the difference of two squares. I can take the square root of that and the square root of that. So I could really write that as, well, and let's flip this one around so it matches the other one. Okay, and we're going to write this as the difference of two squares. 1 plus the sine of theta and 1 minus the sine of theta. Okay, and that is going to make life a little bit easier because look what happens here. I can take one of these and one of those and cancel it, and I'm left with 1 plus the sine of theta over 1 minus the sine of theta, which this matches this. So it worked. So see, what we found had nothing to do with the left or right side. We just changed this into something, and compared the two and got the right answer. Okay, so that is it for lesson 5.2. So the next video will just be over the problem sets.